So for both exponential and logarithmic equations, if your bases are the same, then, and you have an equal sign, then the exponents must be the same. Okay? For both exponential and logarithmic equations, if the bases are the same, then the exponents must be the same. So the way that this comes into play is as follows. If I have 9 to the 2x is equal to 27 to the x minus 1, I want to know what x is equal to. And the first way I would go about doing this is I would try to rewrite both 9 and 27 as the same base with an exponent. Are these both powers of the same number? What number would that be? 3. 9 is 3 to the what? So 9 is 3 squared to the 2x. What is 27? 3 cubed to the x minus 1. So what do I do here? What's this left-hand side going to be? 3 to the 4x. How about the right-hand side? There you go. Where students mess this one up is they don't distribute. This is a multiplication problem. That 3 has to multiply times both of those. Any question on the work I did so far? And what I said is if the bases are the same, then it means you know the exponents have to be the same. So ignore the 3's now. And you're done. Once you get the bases the same, then you can ignore the bases, and the exponents have to be the same. Any one of the exponential problems for the first group that they set up for you, you're going to be able to rewrite them as common bases. Later on in this section, we'll be able to do it if you can't come up with a common base. Any questions on that one? Straightforward? How can you check your work? So this would end up with 9 to the negative 6th, and then 27 to the negative 4th. Okay? And those two should hopefully equal out to be the same thing when you get all done. So let's talk about this step right here, going directly from here and here and dropping the 3's. I actually did a mathematical operation. I can't just get rid of something. Okay? I can't just make numbers disappear and hope everything works out right. I did a function on both sides of that equation. Does anybody know what function I took both sides of that equation to? Okay, so let's go back and think about like elementary school. If I take number 3 and add 4 to it, what do I have to do to it to get back to 3? Okay. 4 and negative 4 are inverses of each other. Addition and subtraction are inverses of each other. What is the inverse of 3 to the? No, 3 to the is not cube root. Something to the third would be the cube root. What is our inverse function for exponentials? What is our inverse function for exponentials? Logarithms. What is the inverse for 3 to the x? Log base 3. If I take the log base 3 of the left-hand side and the log base 3 of the right-hand side, inverse functions performed consecutively do what? Cancel each other out. Inverse functions performed consecutively cancel each other out. So I'm just left with the 4x. Inverse functions performed consecutively cancel each other out. I am left with just the 3x minus 3. We actually did a mathematical operation there. What was nice is we were actually able to take the same logarithm of both sides in order to find our answer. Later on, we're not going to be able to take the same logarithm of both sides because they're going to have different bases. And you're going to have to be able to convert between bases using the change of base formula that we did before. Okay? So, do a simple example first, and we will go a little bit beyond that. So, the next ones are calculator type problems. This one, that's like doing your head problem. Here's one that you can't do in your head. Two to the x equals 5. I want to solve for x. How do I get rid of that 2? What's the log base 2? Anytime you got 2 to the, or a number to the, you do the log base of whatever that number is. So I'm going to take the log base 2 of the left-hand side. If I take the log base 2 of the left-hand side, I must take the log base 2 of the right-hand side. So I'm going to actually show the work in the steps this time. Logarithm rules. I have a logarithm with something with an exponent. What can I do with that exponent? I put it in front. So this x goes in front. This is what cancels each other out to give me 1. Log base 2 of 2 is 1. Log base 7 of 7 is. Log base 90 of 90 is. Log base squiggle of squiggle is. Log base of a number with the same number is always 1. So that's a 1. So you're left with x equals log base 2 of 5. That is the exact answer. If you want an approximate answer, you're now going to use the change of base formula, which is it's exactly the natural log of 5 over the natural log of 2. And at this point, you would give me it's approximately and round it to however many decimal points I tell you to. Don't just stick it into a calculator and give me a decimal point answer, because the questions on the quizzes and tests will say provide the exact answer and then the approximate answer rounded to a certain number of decimal points. This is your exact answer. Well, if I say exact answer, you would stop right here. If I say the approximate exact answer and the approximate answer rounded to 3 decimal points, that's the exact answer. Whatever I tell you to, whatever the book says.
So are we not graphing?
This is not a graph. This is solving. Do you see the word G up there?
No.
Okay.
Yeah, cool.
Well, I see the letter G.
Okay. Okay. Let's do a little more complicated. 4e to the negative 0.3x minus 7 equals 13. Yeah, before you can do the log to the both sides, you have to get the exponent by itself, the exponential by itself. I can move 7. And if I move 7 by doing what operation? Adding it. So that gives me 4e to the negative 0.3x equals 20. Next step. Wrong. Have to divide by 4. I have to have the exponential by itself. Remember when we were solving square root equations? We had to get the square root by itself on one side of the equation? Yep. Same thing here. When I'm solving exponentials, I need to get the exponent by itself. So I have e to the negative 0.3x equals 72. Okay, 5. Okay, so yes, I would then take the natural log of both sides because the log base e we can just write as the natural log. And then what can I do with the exponent? I move it in front. And the natural log of e gives me, if you're stuck, put it in the calculator. 1. That's a log base e of e. And we just said that the log base squiggle of squiggle is 1. So that's 1. That's the whole reason why I took the natural log. So how am I going to get rid of that negative 0.3? Okay, divide by it. So x is equal to the natural log of 5 divided by negative 0.3. Notice the 5 isn't divided by the negative 0.3. The whole natural log of 5 is divided by the negative 0.3. That is the exact answer. If I ask for an approximate answer, because it's in forms of natural logs or log base 10s, you can directly stick that in the calculator and give me an approximate answer. So if you're solving an exponential equation, you want to get the exponent, first easy thing is, hey, can I equate my bases? And then they'll both disappear. The bases will disappear when I take the log base, whatever base is on each side. Next thing you want to try to do is get the exponential by itself and then take log base, whatever the base is, to get those things to cancel out. That's basically how you're going to solve exponential equations. What is the domain of my exponential equation? What's the domain of my exponential equation? What x values are allowed? All of them. So you never have to check your answers to see if they make sense. Remember when we did square root functions, we had to put our numbers back in to make sure we were not taking square roots of negative numbers? We don't have to check on exponentials. However, on the next part, when we do solve logarithmic equations, when we get answers, we need to make sure our x's are above 0, because we cannot take logarithms of negative numbers. Okay? So let's do some logs. So the first one, again, will be an easy one. Log base 5 of 4x minus 7 equals the log base 5 of x plus 5. No, I don't want to take the log base 5. What is the inverse of a logarithm? An exponential. Okay, at the beginning I said if you have the same bases, you can just make the bases disappear and worry about everything else, right?
Yeah.
So I can do this, and that's the work I'm going to end up doing. What the mathematical operation we're actually going to do is we're going to do 5 to the both sides. We're going to do 5 to the both sides. That's what allows that to happen. If you take a 5 to the log base 5, they cancel each other out, and it gives you 4x minus 7. 5 to the log base 5 cancels each other out, which leaves you with x plus 5. And x equals 4. Is 4 above 0? So it's a valid solution. Actually, I don't care if that's above 0. I care about if this is going to be above 0. 16 minus 7, is that positive? Yes. Is 4 plus 5 positive? Yes. I care about what's in the parentheses. Are those positive? Not necessarily the x, but what I'm taking the logarithms of. Any questions on if I got the same base on both sides? Now let's do one where I just have a single base. I'm going to do log base 4. log base 4 of 5x minus 1 equals 3. So based off of what we really did to get rid of the logarithm last time, what am I going to do to both sides here? The 4 of the actual term is called exponentiate. We're going to exponentiate both sides. We're going to do 4 to the log base 4 is, this is going to be my 5x minus 1. 4 cubed is, there we go, 5x is 65, x equals 13. Make sure I'm actually going to get a positive number in here. 65 minus 1 is 64. I'm good. So when you're solving these problems, you need to be prepared to come up with whatever this number is raised to that power in order to do the work. So we've done fairly straightforward. We've done the same bases on both sides. We've done one with a single base that was the same. Now let's do one that has different base. Well, one that's a little more complicated, let's say that way. We're going to do, I can't do it with bases that are different because I have to raise both things to the same thing. And you would use a change of base formula for logarithms to make the second base the same as the first. And I don't think I have any that are that messy. But I do have one like this. Log of 5x plus the log of x minus 1 equals 2. I know how to do it if both sides have the same logarithm with no other numbers. I know how to do it if I've got a single logarithm. Wouldn't it be nice if I just had a single logarithm on the left-hand side? So how can I make a single logarithm on the left-hand side? Distribute. Okay. So you mean type log x minus log? Okay. Logs are functions. They're names. We can't distribute names. But we do have properties of logarithms. And the logarithm of a sum is what kind of problem? It's a multiplication problem. This part right here turns into the log base 10 of 5x times x minus 1. Now, do I have a single logarithm? What am I going to do to get rid of that single logarithm? With what number? Exponentiate with a 10. Uh-oh. That gives me 5x squared minus 5x equals 100. What kind of equation is that? It's a quadratic. So in order to solve a quadratic, you need to move everything to one side of the equation with a 0 on the other. 5x squared minus 5x plus, that would be a minus 100 now, equals 0. First thing I want to do before I try any factoring is to factor out the greatest common factor. Pull out a 5. Actually, I can divide everything by 5. What's 0 divided by 5? 0. So I'm now left with x squared minus x minus 20 equals 0. Two numbers that multiply to negative 20 that add to negative 1. They're going to have opposite signs. Which one's negative? The 5. The biggest one has to be negative to get that one a negative sign. So I solve this now. I get x is equal to negative 4 and x is equal to 5. What I need to do now is to see if I have to throw any of these out. Let's put the 5 in up here. Can I take a logarithm of 25? Is 25 positive? Okay. Is 4 positive? Okay, and then put the -4 in. Can I take the logarithm of -20? No. So you would cross off that solution. Guess I am almost done. So your homework on page 272 to 273, this is assignment 4.6a. It's problems 5 to 10, 14 to 21, 54 to 58. There will be another assignment out of this section on Monday. In just a second. Are there any other questions on this? Have fun.
Guess what?